Hey, how's everyone doing? I hope you guys are all doing well. Today I'm going to be talking about the binary in-order traversal problem. And there are two ways that I'm going to be solving this problem. The first one recursively and the second one iteratively. But to get a better understanding of what this problem wants, it simply wants us to traverse all the nodes in a binary tree and list them in a certain way. So in order means that for every pair, so for every triangle in the tree or every parent and two children, it wants us to print the children first, and then it wants us to print the left child, the parent, and then the right child. So you can think about it in a way where order means left and right children, and then in means we want the parent in between them. So if you look at this tree, the in-order traversal of this tree would look like 1. So this has no left children, so it's going to print the root, and then it's going to go here and print the right child, where it would, and then here it would print the left child 3, the parent 2, and then the right child. So now I'm going to try and solve the problem recursively, and when I mean recursively, I'm going to be writing two different functions, so an in-order traversal function and another smaller quote-unquote in-order traversal function, which I'll be calling from the parent function. We'll call it in-order traversal recurse, and it's going to be taking the same thing, an arbitrary node. By the way, root here does not mean the root of the tree necessarily, it just means an arbitrary node. And I'm going to be passing another array to store the elements, the resulting array, which I'm going to be returning as the solution to my problem, into this recursive function. And what this parent function is going to do simply is just define this resulting array. Initially, it's going to be an empty array. It's going to call this secondary smaller function. It's going to pass it the root of the tree initially, pass in res, and then at the end return res. And now for the implementation of this smaller recursive algorithm, we're going to look at the initial root, the initial node that's passed in. And of course, if the root is not null, or is not none in terms of Python, we're going to do some computations on it. And if it is, then we're not going to look at it. So if the root is none, what we first want to do is, because it's in order, right? So we want to look at the left child. We want to call the function on its left child. And then pass in the resulting array as well. Then we want to work on the parent of this little triangle, or work on the middle element. So we want to append root.val. We just want to append the value, and then we want to call the function again on its right child. And then it's as simple as that, honestly, because the recursive nature, the problem really has a recursive add element to it. And if you just can define the problem in a recursive way, it's really easy to get a recursive solution to it. So as you guys can see, this works. And now I'm going to be looking at a more difficult way to implement it using a iterative solution. Now, in order to solve the problem iteratively, we're going to need two different arrays. So as the first solution, we're going to need a result array, but now we're going to need an intermediate stack, which is going to represent the call stack, which we didn't have to worry about in our recursive solution, which Python took care of in our recursive solution. So we're going to have a pointer called current, which we're going to point to certain elements in the tree. And what we want to do is iterate while based on two conditions, whether current is not none or null, or if the stack is not empty. And what we want to do is go iterate all the way down to the leftmost node in the tree. And how we do that is, while current is not none, so all I'm trying to do right now is get to the leftmost element in the tree. We want to And not only do we want to go to the leftmost node in the tree, we want to keep track of the the nodes that we cross on our way there. And now what this is going to do is give us a path from the root of the tree all the way down to its leftmost child. And then once we do that, we want to pop the highest element in our stack, which would be the leftmost child. Don't forget to insert the 0th index, because when you pop and don't default, it's going to pop the last element. And then once you pop that, you want to append the value of current, and then switch current to the right child. And what this is going to do is allow you to worry about the right child, and in case if it's none, then we don't have to worry about it. We'll just move up the stack and work our way up that way. So just to explain the solution a little bit more, I'm going to be going through a simple array, a simple tree, through the iterative solution, just to give you guys a better idea of how it works. So as you guys can see, our tree looks like this, and the correct in order traversal of the elements of this tree is going to be left child of this root, which is 2, the parent 1, and then it's going to look at this tree as a whole, 3, 4, 5. And instead of just printing the value of the root, it's going to go to this left child 4, then the parent 3, then the right child 5. And now that all the elements of the tree have been traversed, this iteration is done. This search is done. So what we're going to be doing now is going through the iterative solution. What we have is a res array and an empty stack to begin with, and a current pointer which points to the root, which is 1. And now it's going to go to the left, and every time we go to the left, we're going to be populating our stack with the node. So it's going to have a reference to both its left and right element. So it's going to go to 1, then it's going to go to 2, then it's going to go to null. And once it's at null, the stack is going to look like this. It's going to have 1, and then it's going to have 2. And then once we know it's null, it's going to pop 2 out of the stack, and current is going to point to the first element out of the stack. So current is now going to point to 2. Current is now going to point here, and our element is going to be empty. We're going to pop it out of the stack. So this is going to be empty, and current now points to 2. So once we pop it to 2, we're going to insert it into our resulting array, and then current is going to equal to current.write, which is now here. So that's also none. Now that it's none, we are going to have to pop another element out of the stack, which is 1. So now current is going to equal 1. We're going to insert it into our array. We're going to insert it into our array and into our resulting array, and then current is going to equal to current.write according to a code. So now current's going to point here. It's no longer going to point here, and our stack is going to be empty. And now we're going to go through another iteration of the whole loop. We're going to insert 3 into here, and then we're going to insert 4 into here, and then current is going to point to null. Now instead of current is going to point to null now, and then since current points to null, we're going to pop out an element out of the stack and repoint it back to 4. So now that it points to 4, we're going to insert it into our resulting array. We're going to take it out of the stack, and then current is going to equal to current.write, which is none, right? Current.write here is clearly none. So current is going to point to a none value. And now we're going to have to go through another loop of the parent while loop, and now current's going to point to 3. The current's not going to point to 3, current's going to point to 3 after we pop it out of the stack. So now, these are gone, and 3 has been popped out of the stack. We're going to insert 3 into our resulting array, and once we're done with that, current's going to equal to current.write, and we're going to go through another iteration of our while loop. And what we're going to do is insert it into the stack. Since current is not none, we're going to insert it into the stack and then iterate through it again. So it's going to point to null, and now it's going to point to none. It's going to point to the left of 5, and then it's going to pop 5 out and then point back to 5. So if it's going to look like this now after a certain point, and then we're going to insert 5 into the stack. We're going to insert 5 into a resulting array, and current is going to point to current.write, and we're going to be going into another iteration of our parent while loop. Now, if you guys remember, the conditions of the parent while loop were if current is not none, so current is none, and if stack is not empty, and stack is empty, so we will not be going through another iteration of the while loop, and we're simply going to be returning res, which looks identical to our correct answer. And as you guys can see, this iterative solution is kind of hard to wrap your mind around. It is a medium problem after all. However, we have found a one-size-fits-all solution and a set of steps that works for traversing any tree in an in-order manner.